Hello everyone and welcome. In this video, I will be talking about hydropower. So this video is a continue of our series that talks about renewable energy. So first of all, let's talk about it. Let's explain again what is renewable energy. Is the energy source that comes from natural resources such as sunlight, wind, rain, and tidal and geothermal heat. So these are all natural sources of energy. They most of them do not have pollution to the atmosphere, and they are renewable. So renewable energy technologies range from solar power to wind power to hydroelectricity, micro hydro biomass, and biofuels for transportation. So biofuels can be also used for transportation as well. So let's go back to hydropower. What is hydropower? It refers to the energy that's mostly the electric energy that comes out from the motion of the water. So basically, the water is moved through turbines, and this turbine will, and the water will generate mechanical power using the turbine. And then that turbine will basically be connected to a generator, and that will generate electricity. The main advantage is that it's clean and renewable. So this is a schematic of a type of hydropower plant, which is called the Francis hydropower plant. And it's clear that the water moves from the reservoir to the turbines, and then the electricity will be generated in that way. So basically, the turbine, the height here can vary depending on the type of turbine that's used. Different types of turbines will have different optimum efficiencies that run on different altitudes of the water or the head of the water. So in the Francis turbine, the optimum um, the optimum height doesn't has to be that high. So it can be very efficient at relatively lower altitudes or lower heights. So there are social issues related to building dams. So the main one is related to people, where it's hard for the government to remove the people from the area, and as they change the the nature of the environment as they building the dams. So there will be cultural issues, religious beliefs, and other things related to that. So although many countries they try to give alternative benefits to the people that live there, but it's never 100% satisfactory to them. This is this is an example of a dam and the way how it looks like. This is a very big dam. We have another example here as well. So let's talk about the advantages of hydropower. Once a dam is constructed, electricity can be produced at a constant rate. So there will be always electricity produced as long as there is water. If electricity is not needed, then the water gates can be closed and water can be reserved. Dams are designed to last for many decades and for many years, so they can generate electricity for a very long time. Number four, the lakes that form behind the dam can be used for other uses like water sports, and also large dams can be a tourist attraction. And lakes water can be used for irrigation purposes, which means they can be used for agricultural purposes. Talking about the disadvantages, dams are extremely expensive to build and must be built to a very high standard because it can be very dangerous if the dam is not constructed with very high standards. The high cost of dam constructed means that they must operate for many decades to become profitable. The flooding of large areas of land means that the natural environment can be destroyed, and it can affect the area which lies before the dam, even after the dam or the water. People living in villages and towns that are in valleys, that are in a valley, they are in a risk of, of flooding. And this means that they must move outside their places. And this is sometimes can be done forcibly by the government, which is a huge disadvantage. The building of large dams can cause serious geological damages. There's an example of the Hoover Dam in the USA. It actually triggered a number of earthquakes and has depressed the Earth's surface at its location. Significance of hydropower. Hydropower stands as the most significant renewable energy source since it only relies on moving water or the potential energy of water. And it is relatively simple, a simple concept, but it also as much as it's simple, it competes with the fossil fuels and nuclear power. And although it is much cleaner than both fossil fuels and nuclear power, hydropower does not pollute the atmosphere or environment, which is basically the whole idea about the renewable energy and its relation to hydropower. That it's renewable and also it does not cause any pollution to the atmosphere and environment. Some facts about hydropower. Hydropower uses the energy of moving water for a variety of useful applications. Hydropower generates electricity by harnessing the gravitational force of falling water. Hydroelectricity in 2006 supplied around 20% of the world's electricity. Most hydroelectric power stations use water held in dams to drive turbines and generators, which turn mechanical energy into electrical energy. The largest hydroelectric power station in the world is the Three Gorges Dam in China. This is another schematic of how the hydroelectric power plant works. So there's the water in the reservoir, which has a high head, and then which also has a very high potential energy. It goes through passages into through the dam into the turbine. Depending on the turbine type, then the turbine will rotate, producing energy at the generator. The electricity will be also going to its places like the houses, the areas, or maybe batteries to be stored in some situations, and then the water will go down to the river after that. There are mainly two types of turbines. One is called the impulse turbine, the other is called the reaction turbine. So in the impulse turbine, the water will be forced through a nozzle. So the nozzle will create high speed, high velocity of the water, and then this water will be injected to the buckets of the turbine, and therefore there will be a tangential force on this side, and also the side that will both cause a moment and also turn the turbine. In the reaction turbine, it works a different way where the water is pumped through the tubes or through the housing of the turbine inside, and then the angle of turning here will create a reaction force. This reaction force, as the pressure is high, it will force the turbine to rotate in a direction. So there are differences between both of them. The impulse turbine, the steam flows through the nozzle, like how I explained, and hits the moving blades. Although in the reaction turbine, the steam flows through the guide mechanism and then into the moving blades. In the impulse turbine, the steam impinges into the buckets with kinetic energy. But in the reaction turbine, it will be using pressure and also kinetic energy. In the impulse turbine, the energy may or may not be admitted over the whole circumference, but in the reaction turbine, the steam pressure is reduced during its flow through the moving blades, and it also goes through the whole guidance. In the impulse turbine, the blades are symmetrical, and in the reaction turbine, the blades are not symmetrical. Thank you for watching. I hope that you have learned something from this video, and thank you so much.